couple of big ideas in terms of shading spheres, okay? Spheres require that we really study the ellipse and we learn how to use it. So the ellipse is a circle in perspective, okay? And so when you have a sphere, when you're drawing a sphere, if you take a line and you pass it around the sphere, like directly around the center of the sphere, you have an ellipse, okay? Now, I'm so sorry about how fuzzy this is. I gotta buy a new camera. There's nothing that I can do to get it to focus any better. I gotta work that out, okay, guys? But for the meantime, we'll just have to make do with this, all right? And know that I feel bad and I'm sorry. Okay, but back to, I'm just gonna overdraw these things so that the computer picks them up. Okay, so this is an ellipse. Now the ellipse has this rule. There's a line that breaks the ellipse in two. This line is called the minor axis. And I want to be using that word all the time, minor axis. I want to be using that phrase all the time, okay? And what we get is we get side A and side B are symmetrical. Okay, so if you're trying to draw a sphere, and you get yourself into something that looks a bit like a circle, and now we've got an ellipse passing that could represent the close side of it and then go around and be the far side of it, and it has a place where it's split in two. That's the minor axis. Now we're talking about this in terms of shading, okay? We're inside of a section on shading, and here's what you're going to find out is that you've got the sphere, okay? You've got a light direction. Here's my light direction. The light direction forms a minor axis for an ellipse, like say right here. That shows us the shape of our shadow on a sphere. So if you were going to draw a sphere and shade it, like let's take a sphere and shade it, imagine that my shading went like this. See how that just looks wrong? It doesn't have the volume, the same effect of volume that you're going to get right here. Makes sense? Okay. So we use that. So we take a sphere, here's a sphere, and we'll light it from that side. I can take and use that as a minor axis right here. Now it's a little more complicated to show you, like if the light direction moved back into the paper or came out from the paper, but let's say for instance that it did. Say the light was coming down like from this angle, but also say it was turning up that way. And now what I would do is I would move the ellipse to something like this, right? And this would be the part that would be shaded. And let's say that I was going to do it the other way. Say I'm going to move, here's the minor axis, but I'm going to move it through that way, deep into that, right? And now I might end up with something like this. And now this would be the section that was shaded. Okay, so depending on where the light is coming from in this axis as well as this axis, right? Like where does it go this way and that way? And this one is showing us really the light is deep in but on this axis. So it's coming like from that direction really, okay? Okay, so that's the first thing that we have to know about shading spheres. The next thing that we have to know is, let's go back to our true value. So let's say that this sphere here is true value of 1. Okay, now when we get to where the shadow comes in, here's my shadow. Remember that the shadow value on here is about a 4 or 5. Okay. Now, if we include reflected light, let's say there's some light coming up over this way, coming up that way. So if we darken this edge just a little bit, and this edge ends up being referred to as a terminator or a core shadow. And now as we turn out towards the light, what we need to do is we need to, let's say that this is our lightest section right here, and we need to gradually split this value in gentle transitions moving up to what will become the highlight. On a sphere, all the transitions are really gradual. Okay, so you see how 3D, and if I start to include occlusion, you see how 3D that starts to look? I wonder, yeah. So let's do one more. Here's my light source. Now the next thing that you would want to know too about spheres, well, we'll just shade one. So this is my light source is moving in that direction. So that's going to become the minor axis. This time I'm going to, on this axis, I'm going to bring the light out towards me. This becomes my terminator edge, my core shadow edge right here. And I can gradually start to transition over. And my highlight is going to be here. And so all of this is going to be lightening up until it hits. It's going to go, it's going to, from this it just starts to lighten, lighten, lighten until it gets to there. Okay? And that's how we get these to look. And if you look up and it looks like it's too abrupt, all you have to do is go back to your transitions and try and make them more gentle. Try and make more beautiful, gentle transitions. Okay, and the last thing that you want to know in terms of spheres is that if you have a sphere and you have a light direction coming this way, again, if this is our ground plane, my ground plane is going this way, let's say, or my ground plane can be going that way. If I hit here, and you're imagining the sphere has an ellipse inside of it, right? So I'm hitting here, and then when it gets to the ground, there's an ellipse projected onto the ground, and the ground, you need a line perpendicular to the ground to show you where how the cast shadow sits, like the shape of the cast shadow. So this is a low light source, and here is the ellipse on this object for the light. And we'll have a little bit of occlusion down at the bottom in here. And I'm going to darken up for my core shadow. And I'm going to move up to the light. As I move away from the object, lightening a little bit in the cast shadow. Okay, and that's what you need to know so far as shading spheres is concerned.